Introduction to geometry, the basic vocabulary. So the first thing here is a point, and the point is the most important thing that we need to know in geometry. Everything, every concept, the definition, the figures, whatever you do, it involves points. And this point doesn't have a well-defined definition, but we just assume that traditionally it is thought of as having no length, width, or thickness, and often a dot is used to represent this point. So a point is something like a dot, and that dot can be named as this is a point P, we can say. Now I have here in this space there are infinite number of points, and each one of these points are unique. For example, if you want to name this point, that's a point, I'll call it as point A. I know that point A is connected to point B. So when you connect those points, what happens? We get from this point A to point B, there is a straight line. Now this line, in fact I should have said line segment, because it is having this point A and point B, the starting and the ending point. It is consisting of infinite number of points. Similarly, if you take a triangle, this triangle has number of points inside the triangle. You call it as interior of the triangle. There are so many points outside, those are exterior points, and also infinite number of points are there on the triangle. Okay, so this is all about a point. Just remember that a point is a dot, and it is named by using uppercase letters. Usually we use this capital letters like A, B, P, Q, R, etc. Now the next word that we have here is a straight line. Okay, we have a line. It is one of the basic undefined terms of geometry, traditionally thought of as a set of points that has no thickness, but its length goes on forever in two opposite directions. AB denotes a line that passes through the points A and B. Okay, now we have here, this is a straight line. Like I said, it is consisting of infinite number of points. Out of those infinite number of points, if you name two of them, the first point as A and the other point as B, now you can represent, or we can name this whole line as a straight line AB, or we can also call it as a BA. Now sometimes if we don't know the names of any of these points, no point is given to us, in such case we can just say that it is a straight line L. You can use a lowercase letter in this case. It is a line L, or sometimes in this case you can say this is a line M or N, in lower, even P, Q, R. But remember, we use lowercase letters to represent the whole line L. Okay, here this is the line, actually it is XY straight line, or you can also call it as a straight line N, right? This is M, etc. Now sometimes if you know a third point also in this straight line, suppose there is a point C. Now the same straight line is called as AC also. If you want, you can call it as AC. It represents the same straight line, whether it is AC or CB or BC, all are representing the same straight line L, right? That is about a line. A line is nothing but a straight set of infinite number of points which are satisfying this particular condition of aligning in a line, and it is extended on both the sides, right? Now the third word I have here is a ray. A ray begins at a point and goes on forever in one direction. So what is the difference from the straight line? In straight line, it is extendable on both directions, but a ray has an end point. It has one point here, that is, you can't move on this side. It is an end point, or if you want, you can say starting point here and just goes on to your right. That is A to B, it goes on. And in this other example, I have a ray. If I write here, suppose I'll write P and there Q. Now, how do you represent this symbolically? I have to write it as a ray starting from Q going all the way in that direction. So, Q to P. Remember to write this point, the end point that you have to start with that end point, and another point that is belonging to this ray. Okay, ray is very easy. Got it? Now the next, you have a line segment. A line segment, or in short, you can just say segment. The part of a line between 2 points on the line AB denotes a line segment between the points A and B. So here AB is a line segment. It has you cannot extend it on your left or on to the right, because those A and B are the end points. These are the limits you have there, like you can't go on neither of those two sides. That's why we call it as a part of a line. That's the segment. So this whole thing is a straight line. You have a straight line AB. The symbol is this way. From AB, a part of that line AB is a line segment AB. See the difference in the symbols here. It is a straight line and that is a line segment, which is a part taken out of this one. Okay, that's it about a line segment. Okay, AB, you can also call it as BA. It is just the same. The line AB or line segment BA, it is same. Now the next, we have an angle. Angles are created by two distinct rays that share a common endpoint, also known as a vertex. Angle ABC or angle B denote angles with vertex B. Okay, so we know what a ray is. Just now we saw this is one ray. And another ray also, if it is joined like here, we have a ray BC. BC is one ray. And BA. BA is the second ray. And those two rays have a common endpoint. Right? This B. We are seeing that this B is the common endpoint. Right? Hence, it forms an angle. Now, what is the name of this angle? It is called as A, B, and C. The vertex has to come in the middle. So, we name that as angle ABC, or you can also call it as angle CBA. Same thing, CBA. And in short, you can just say that it is angle B, because in this particular case, we have only one angle. So even if you say angle B, it is understood that it is the same angle. But when you are dealing with more than one angle, we have to give its full name by mentioning those all the 3 points that are lying on this angle, making sure that the vertex is in the middle. The vertex has to be in the middle. Now, okay, what is the vertex? Of course, you know that B is the vertex, the common endpoint. Alright. Now, the next thing that I should know is adjacent angles. Adjacent angles are those angles in the same plane that have a common vertex and a common side, but no common interior points. So, what is the name of this angle? I have here angle CBD. Angle CBD. And the other angle is angle ABC. The first one is angle ABC. And we see that this is ray BC. This BC is common, right? Common vertex and the common side. B is the common vertex it has. See, in the middle we have B and B here. The vertex is the same, and those two angles are sharing one ray BC. BC is the common side that it has, right? Which is called as common side here, that is BC. Alright. And what is not shared? Only the interior points. And what are the interior points? We know that in this first angle, all the points that are here inside are interior points. And in the second angle, all these are interior points. Nothing is common between them. So these two angles, angle ABC and angle CBD, are satisfying the condition to be called as adjacent angles, having the common vertex, common side, and not common interior points. Now the next one I have is a linear. A linear pair is a pair of adjacent supplementary angles. Okay, first let us look at this line. We have to have adjacent angles which are supplementary. Now let us call the first angle as here point A. The common end point, we take it as B, and we have a point C and another point D like the previous one. So the first angle again we have angle ABC, and the second one angle CBD, and they're fulfilling the condition to be called as adjacent angles because B is the common end point. That B, we are finding it here in the middle. B is the common end point and BC is the common side. So those two are adjacent angles. Angle ABC and angle CBD are adjacent angles. Now also the sum of these two angles, on adding the measures of these two angles, the total is going to be 180 degrees, the sum. That is, if I add the measure of angle ABC to the measure of angle CBD, the total is going to be 180 degrees, which is a straight angle, right? That is the and the sum of the two angles is 180, hence they are supplementary angles, right? So the first condition is adjacent, fulfilled here. The second condition, supplementary angles fulfilled. Hence this pair, that pair of angle ABC and angle CBD, are called as a linear pair, right? This one is done, right? From adjacent, the next condition, supplementary, is also fulfilled, hence it got a new name called as a linear pair. Now what is the property of this linear pair? When you exclude that common side, a linear pair forms a straight line. Let me show it to you. Now these are the two angles. Suppose if I just cancel this, assume that this line BC is not there. Just look at the red line. It is a single straight line. When you exclude the common side that is BC, if it is taken away, the resulting figure is a straight line, right? So that is the property of a linear pair, right? Okay. Now in the next video we will be looking at other important things like vertical angles, parallel, transversal, etc. All right. Thank you. Thanks for watching.